Welcome student in the another session of mathematics. Hope everybody has completed the previous exercise. Today I am going to discuss the properties of squares. The first property of square is the square of an even number is always an even number. Let's check it out. 2 is an even number. The square of 2 will become 2 2s is 4, which is also an even. Then I take 4. 4 is even. Square of 4 is 16, which is also an even. Let's check with the 20. 20 is an even number. Square of 20 is 400, which is also an even number. So in the first property, we learned that the square of even number is always an even number. Then we come to the property number 2. The square of an odd number is always an odd number. Let's check the example. 3 is an odd number. 3 square is 9, which is also an odd. 5 is odd. 5 square is 25, which is also an odd number. Let's take 11. 11 square is 121. 11 is odd. 121 is also odd. So we learn that the square of even number is even. Square of odd number is odd. Then I discuss the third property. The square of a proper fraction is a proper fraction less than the given fraction. That means the square of any proper fraction is lesser than the given proper fraction. Firstly, we have taken 1 by 2. The square of 1 by 2 is 1 by 4. So if we compare 1 by 4 and 1 by 2, you can understand this way. You want half of the pizza or 1/4 of the pizza, which is greater? Obviously, half of the pizza is greater than 1/4. So we learnt here that the square of a proper fraction is lesser than the given fraction. We have another fraction 2 by 3. The square of 2 by 3 is 4 by 9. If you compare 4 by 9 and 2 by 3, which is greater? 2 by 3 is greater. So we learned very important property here that the square of a proper fraction is lesser than itself. Then we learned the next property, that is the fourth property. The square of a decimal fraction is smaller than the given decimal. So again, the square of a decimal number is always smaller than the given decimal. Let's see the square of 0.1. The square of 0.1 is 0.001, okay, which is smaller than 0.1. So we learned here the two properties, that the square of a decimal number is less than the given decimal number, and the square of a proper fraction is less than the given fraction. Then we learned the fifth property. A number ending in 2, 3, 7 and 8 is never perfect square. Remember children, any of the 2-digit number, 3-digit number, 1-digit number, 4-digit number, if it ends with a 2, 3, 7 and 8 is never a perfect square. Then we learned another one important property. A number ending in an odd number of zeros is never a perfect square. So if any number has 1 0, 3 zeros, 5 zeros, it is not a perfect square. But if it has an even number of zeros, then it is a perfect square. Let's see with 100. 100 has 2 zeros, so it is a perfect square. It is a square of 10. We can take 10,000 also. 10,000 is a square of 100. So we learned here that if a number ending with odd number zeros is not a perfect square, and if it ends with even number of zeros, then it is a perfect square. Okay children, so we learned the six very important properties. Now I'm going to discuss a few interesting patterns. The first pattern is if you add 1 plus 3, 1 is the first odd number and 3 is the next odd number. 3 plus 1 is 4, that is square of 2. Then I take the first three odd natural numbers, 1, 3 and 5. If we find the sum of first three odd natural numbers, that is equal to 9. That is equal to 3 square. If I take the first 4 odd natural numbers, the sum becomes 16. That is 4 square. So if we have taken 2 odd numbers, the first 2 odd numbers, the sum is 2 square. If we have taken the first 3 odd numbers, the sum is 3 square. If we have taken the first 4 odd numbers, the sum is 4 square. If we have taken the first 5 odd numbers, the sum is 5 square. So we learnt very important pattern here, that the sum of first n odd natural numbers is equal to n square. Whatever the number of odd natural numbers are there, the sum is equal to the square of that number. But remember, we should have first n odd numbers. We should have starting from 1, and it should be having consecutive odd natural numbers. Okay children, we cannot skip any of the natural number in between. That means we have taken 1 and then we take 5 and then we say it is equal to 4 square. That will be wrong. Then I come to the very important another property or another pattern, that is the difference between the square of consecutive natural numbers. We take any two consecutive natural numbers. I have taken 4 and 3. 4 and 3 are consecutive numbers, and I am taking the difference of their squares. These are their squares, and minus sign shows that we are taking the difference. The difference of two consecutive odd numbers is equal to, we know the formula. What the formula is? A square minus b square is equal to a plus b and a minus b. This we learnt in the exponents, na children? So according to this formula, if we solve it, what we will get? 4 plus 3 and 4 minus 3. 4 plus 3 is 7. 4 minus 3 is 1. That is 7 into 1, 7. That means if we are finding the square difference of the square of two consecutive numbers, then it is equal to their sum. Let's see the another one. I have taken 11 and 10. Again, 11 and 10 are the two consecutive numbers. We are finding the difference between their squares. So this, applying this identity, what it gives? 11 plus 10 and 11 minus 10. That give you 11 plus 10 is 21 into 1, that is 21. Okay, so we learn very important property that whenever we are finding the difference between two consecutive natural numbers, it is always equal to their sum. Okay, 4 square minus 3 square is equal to 4 plus 3, that is 7. 11 square minus 10 square is equal to 11 plus 10, that is 21. So we learn a formula here. What that formula is? N plus 1 square minus n square, that is the difference of two consecutive natural numbers, is equal to their sum. This is the first natural number, this is another natural number, so their sum is n plus 1 plus n. It will be very useful when you solve the questions. These types of patterns and properties give you a trick to solve the questions in the competitive exams. Then I discuss one more thing today with you, that is Pythagorean triplet. What does Pythagorean triplet is? See, Pythagoras theorem you know very well. The sum of base square plus height square is equal to hypotenuse square. Hypotenuse is the largest number, longest side, that is equal to the square of the sum of remaining two sides. So now I am going to discuss a Pythagorean triplet. See, I have taken 3, 4 and 5. So if you find 3 square plus 4 square is equal to 9 plus 16, that becomes 25. That is equal to 5 square. Therefore 3, 4, 5 forms an Pythagorean triplet. So if we have any natural number greater than 1, m is greater than 1 and m belongs to n. What the condition is? M is greater than 1 and m belongs to natural number. So m is any natural number greater than 1. Then what the Pythagorean triplet is? It is 2m, m square minus 1, m square plus 1. So we don't have to calculate it here. So if we know any one among these three, we can find the rest too. So what is the standard Pythagorean triplet? It is 2m, m square minus 1 and m square plus 1. I discuss question number 6 firstly because I have already written this pattern. So I am going to discuss question number 6 first part. They are saying write a Pythagorean triplet whose smallest number is 6. Smallest number is 6. See, if I say 2m, m square minus 1, m square plus 1, which will be greater, children? Which will be the smallest? 2m. See, take any number. See, I say take 4. 2 into 4 will give you 8. And the square of 4 will give you 16. So remember, children, the square of any number is always greater than its double. So which is smaller here? 2m is smaller and the m square plus 1 is greater. Even m square minus 1 will be greater than 2m. If I say which is smaller among all these three, the 2m will be greater. Why I am making sure? Because remember, the square of any number is always greater than its double. Let's see with 3. The square of 3 is 9 and 3 2s is 6. The square of any number is greater than its double. So if I say which is the smaller among these three, so 2m is smaller. Okay. So in question number 6, now they say write a Pythagorean triplet whose smallest number is 6. That means 2m is equal to 6. Okay. Smallest number is 6, that means 2m is equal to 6 and we are looking for the Pythagorean triplet. Therefore m is equal to 6 by 2, that becomes 3. Now m square plus 1 will become 3 square plus 1, that is 9 plus 1, that becomes 10. Then we consider m square minus 1, that is 3 square minus 1, that is 9 minus 1, that is 8. So what the Pythagorean triplet is here? 2m, that is 6, comma, then it is m square minus 1, that is 8, and the lastly we write m square plus 1, that is 10. So this is the Pythagorean triplet. We always write triplet in a bracket. I discussed one more part of question number 6 with you. I discuss the third part. What is written in the given in the third part? Smallest number is 16. That means 2m is equal to 16. Smallest number, the moment they say smallest number, which is smallest among these three, that is 2m. So smallest number is 16. 2m is equal to 16. m is equal to 16 by 2, that becomes 8. Now m square minus 1, that is 8 square minus 1, and 8 square minus 1 will give you, that is 64 minus 1, that becomes 63. Then I take m square plus 1, that is 64 plus 1, that is 65. So what is another Pythagorean triplet? 2m is 16, m square minus 1 is 63, and m square plus 1 is 65. Question number 6 has 4 parts. I already have done 2 for you. Hope you have can do the rest of the 2 of your own. Then I discuss question number 1 with you. Question number 1 of exercise 3b I discuss with you. Give reasons to show that none of the numbers given below is a perfect square. See, we learned that numbers which end with 2, 3, 7 and 8 are not a perfect square. Even the numbers which have odd number of zeros in the end will not be a perfect square. So I discuss the first one with you. See, this number ends with 2. So a number which ends with 2 is not a perfect square. Then comes with 3. This number ends with 3. Therefore, it is also not a perfect square. Then I discuss question number first, 7th part. See, this has how many zeros in the end? It has 5 zeros in the end. So it will not be a perfect square. So you have to give the reason for not being a perfect square. Okay, how you'll write? As the number ends with 2, as the number ends with 3, or the number ends with 7. Therefore, it is not a perfect square. For each part, you'll write the reason separately. Question number 2. Which of the following are squares of even numbers? So we learnt in the properties that the square of even number is even number. So can you say me which are the even numbers? The first one is even, so the number must be even. Second part, 729, it is odd, that means it must be a square of an odd number. So similarly, you can decide which is even and odd. Question number 3 now. Which of the following are the squares of odd numbers? The square of odd numbers is always odd. So this number is an even, that means it is a square of any even number. If we look at here, it is an odd number, that means it is a square of odd number. Third one also, it ends with 5. It is an odd number, therefore it is also a square of odd number. So you can write whether it's an even or odd carefully in your copy. Then question number 4 I discuss with you. Question number 4 says without adding, find the sum of the given numbers. So we learned the property just now. The sum of first, whatever it is, odd numbers is always equal to the n square. That means whatever numbers are available here. First one, how many numbers are available? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. If we add all the numbers, it will be equal to 11 square. Similarly, you can do the rest two parts. Then fifth part, question number 5, you have to express 144 as the sum of 12 odd numbers. Then we'll start the sum of odd numbers from 1 plus 3 plus 5 plus 7, then 9, 11, then 13, 15, 17, 19, then we have 21 and then we have 23. Okay, this way you'll write. See, it's question number 1, 4 and 5 are exactly opposite to each other. First, in fourth one, you have to write the answer as fifth one, and fifth one, you have to write the answer as fourth one. I discussed question number 6 with you right now. So I end with this session here only, exercise 3b. Complete the question number 1 to 6. Okay, children? Thank you. Have a good day.